Hey everyone, this is Cyber Defenders, and we have Proxy Shell, a difficult network forensics lab by Cyber Defenders. So, let's read the scenario while the lab initiates. As a SOC analyst, you received an IDS alert indicating port scanning activities on the network. You are provided with a PCAP file containing captured network traffic to investigate further. It is crucial to note that during this period, threat actors were known to exploit the proxy shell vulnerability. Your task is to analyze the network traffic and uncover any signs of malicious intent. Now that the lab has booted up, let's check what we have. In the challenge folder, we have two files, a PCAP file and SSL keylog, which contains the TLS session keys. Then, going into the tools directory, we can see Wireshark, Zui, which was formerly known as Brim, which is a graphical interface for exploring data. We also have Network Miner, John, and RockU. The presence of John and RockU suggests we may need to crack a password later on. Starting with the first question in the lab, it says, what is the attacker's IP address? I started with launching Network Miner, then I dragged the PCAP file onto the software, and upon scrolling through the hosts, I could see one IP identified as a Nmap Linux host. This is very likely the attacker's machine, so let's submit that as our first flag. On to question number 2. Analyze the PCAP using Brim. You will get an alert related to the Nmap scan. What is the alert's signature ID? I started Zui, then I dragged the PCAP file, and after searching for the term Nmap, the first result was an alert event. Diving deeper into its details, I identified a pattern resembling a Suricata signature, including a signature ID, which should be the answer that we are looking for. Question 3 says, multiple vulnerabilities were chained together to exploit this attack chain. What is the CVE of the chained vulnerabilities? Submit the answer in ascending order. I started by Googling proxy shell CVE attack chain, and I could already see 3 CVE numbers in the second result. So I copied them and arranged them ascendingly before submitting. Question 4 says, Shudan posted a search query to track vulnerable Exchange servers. What is this query? In this question, I just Googled Shodan proxy shell vulnerable servers, and the first result was a tweet from the official Shodan account. They linked to a Shodan report that had the query at the very beginning, revealing our flag. Question 5 says, the attacker was able to read the inbox of the A Shawqi user. What is the endpoint used to read the emails? I launched up Wireshark and used the find packet option to search for the given string within all of the captured packets. I tried searching in packet list, then in packet details, and finally in packet bytes, but none yielded any results. Then I remembered we had the TLS decryption keys for the captured packets, so I went ahead and launched my terminal and used edit cap with the inject secrets option to inject the TLS keys onto the PCAP file. The result should be a new file called out.pcap. Now, if I just open the out.pcap file with Wireshark and do the same search again, we can see some results. It's also worth mentioning that you can perform the traffic decryption within Wireshark. So, to demonstrate that, I will delete the out.pcap file which we just made, and I will open the old pcap file that contains the encrypted TLS traffic, which, as we can see, doesn't show any results when we look for our string. So, we head to the Edit menu, then Preferences, and from the Protocols list, we look for TLS. Then we can see an option to select a secrets log file. So we just select our SSL key log file and press OK. And now that the traffic is decrypted, we can search for the A Shawqi, which was the user that had his inbox read by the attacker. My next step was to follow that packet's HTTP stream. This would give us some context on what was the request and response related to this packet. We can see some XML logging data, but I will just exit from this view, which shows the entire HTTP conversation. And let's try to understand each packet individually in this conversation. I noticed that the first packet in this conversation was a post request to an O2 Discover endpoint, which Microsoft Exchange uses to configure and retrieve data from a mailbox. Looking through the packet data, I could see that it only contained the HTTP headers for the post requests. This means that the body for the request should be in another packet. And it was the case. Going to the second packet in this conversation, we can notice that Wireshark classified the protocol as HTTP2/XML, which means that we should find some XML data embedded in the packet. And we were able to confirm this by looking at the packet's data. Having a deeper look at the contents of the XML, we notice it uses SOAP, or SOAP, which is an application communication protocol. It basically tries to retrieve all the contact data of the users in the network. Then, proceeding on to the third packet in this conversation, we can see that the source IP is the destination IP of the two previous packets. This means that this packet probably contains the response to the post request, and we can verify that by checking the data for the request, and specifically the 200 response code, which indicates a successful request. Skipping the next two packets as they seem to not contain anything significant, we inspect the last packet in this conversation. We notice it is of type HTTP2/XML, which indicates that it may contain the request's response payload. I will right-click on the XML object and click on Show Packet Bytes. This will show the XML payload of the response. It is very messy and not properly formatted, so I will copy it over to an online XML formatter, and we can start inspecting the response. I could see 4 resolved contacts, each containing the email address and the full name along with more information about the contact. So in short, this HTTP conversation requests all the contact information and receives a response with such information of 4 of the users on the system. So I will colorize these 4 packets so we are able to distinguish them when we go out of the filter. Now, I will remove the TCP stream filter and only keep the HTTP stream part to see all the HTTP conversations after this one. This will give us more context on what is going on and why this information was requested from the server. Right under the conversation we just analyzed, we can see a new post request to the same endpoint. So let's see what is being requested this time and what the response is. I will follow the HTTP stream for this request just like we did in the previous one. We can see a pop-up that just appeared with the full HTTP request and response. But I will close that for now and focus on the packet with the HTTP request only. As usual, we can see that the first packet is just headers, so I will skip that and head straight to the XML payload. I will press Ctrl-Shift-O to view the packet bytes, and we can see that an auto-discover request is being made on the ashawqi@cyberdefenders.org email, This is just a way for the server to request configuration information for this email address. Now, let's see what is the response for this request. I will click on the last packet that should contain our response. We notice some HTTP headers at the beginning, but then we can see the start of an XML object. So we press Ctrl Shift O to view the bytes of that XML object. I will copy the XML over to our online formatter so we can have an easier time reading it. And scrolling down, we can see a bunch of information about the user and the endpoint to which his email server is configured. If we recall, question number 5 was asking about the endpoint used to read the mail of the Shawqi user. So, this means we finally found the answer to our question. Let's submit our hard-earned flag. Going on to question number 6. Analyze the email read by the attacker. What is the sender's email address? It sounds like we are on the right track, so let's keep following the HTTP conversations. I will also colorize this conversation with a different color so we know that we have already been here. And then I will go back to the HTTP streams. As usual, I will choose the first HTTP request of the third conversation and will just follow it in the stream to focus on that conversation only. Then, inspecting the XML payload of the request, we notice it requesting information about the emails in the user's inbox. Let's see the response for this request, as this probably should contain some interesting information. So I will go back and view the bytes for the XML payload of the response packet. I will also copy the XML over to the formatter that we have been using. And it becomes clear that two emails are being returned. One email has the subject, to-do list, and the other email has the subject, password reset on Cyber Defenders. We also notice that each email has an ID, which should be relevant if the attacker tries to request the email contents by ID. So let's colorize these packets and we can return to the HTTP conversations. Now, I will follow the HTTP stream of this conversation. Then I will inspect the XML payload for the request. Immediately, I was able to recognize the ID in this request. It's the same ID we saw in the last response, which means that the attacker is trying to request the email contents with the to-do list subject. To confirm this, let's check the response for this email. However, it seems that the entire email body is base64 encoded, so I will just decode the whole thing as base64 from the drop-down menu at the bottom. Once we do that, we can see all the information about that specific email, including the sender and the receiver. And if we recall, the question asked about the email address of the sender. So let's submit that. As for the next question, it says, what is the secret flag hidden in the email? I continued reading the contents of this email that we have just decoded. It says, check this list for upcoming tasks in the email body. Then it seems to have a zip file attached, which seems to be base64 encoded. So I copied over the base64 data for the zip file and I will open my terminal and create a new file that contains the base64 data. Then I cleaned the new lines and saved the file. After doing that, I decoded it into a new file called out.zip, and running the file command identified the file as a zip archive. So this means we are headed in the right direction. I tried to extract the contents of the zip file using 7z, but it seems to be password protected. But I also remembered having John in our arsenal of tools, so I just used zip2John to extract the password hash from the archive, which we'll then feed to John the Ripper to crack for us using the RACube word list. And we successfully cracked the password, which is Liverpool. I will then try to extract the archive using the cracked password, and we can see it wrote a new file that contains our flag. So let's submit that. Question 8 says, the attacker dropped two web shells. What is the file name of the first web shell? To solve this question, I thought it would make more sense to use Zui to explore the requests for any web shells. So I launched it and noticed that every HTTP request had a URI field. So I just used the count function on this field to view all the different URIs in our PCAP file. There were only 22 unique results, and none of them had anything to do with the web shell. It was when I remembered that a lot of the requests were encrypted, and we couldn't decrypt the requests in Zui. So I had to find a workaround. I went down a rabbit hole exploring Wireshark data with Zui. Instead of using Wireshark directly, which seemed more complex, I aimed to export decrypted HTTP packets from Wireshark for analysis within Zui. And to do that, I went to Wireshark and filtered by HTTP requests. Then I was able to find some suspicious requests. To export these requests, I went to the File menu, then clicked on the Export Packet Dissections and chose JSON, which should be supported in Zui. Loading the JSON dump in Zui, I noticed that all the packets were inside an array. So I used the over this query to get rid of the outer array and generate the elements of the array as a sequence of records. Then I inspected a random packet and found that the HTTP frames are nested inside a dictionary. So I did more Zui magic to extract the frames from these nested dictionaries. Then I queried for HTTP frames. I noticed that each HTTP frame stores the full URI of the request, so I queried for that as well. Then I piped the results onto Unique to remove any duplicates and focused on the last couple of lines, which seem to be the web shell traffic. However, they are URL encoded. So, to make our analysis easier, I went over to Cyberchef to decode them. And it all started to make more sense. I could see that some requests were being made in the beginning to a weird ESPX file, which is the first web shell being used. So let's submit that as our flag. Question 9 says, what is the first command executed by the attacker? Going back to the HTTP request URIs, we can notice that the first command that was run was who am I. So we can submit that. Lastly, question 10 says, the attacker was able to read a file from the system. What is the contents of this file? Going to our web shell traffic, we can see two attempts to read a file called important.txt. I will head back to Wireshark and search for the string important.txt. The first result contained nothing, and this is probably the first attempt to read the file. So let's check the request for the second attempt. Going through the results and following the HTTP stream for the second request, we can see the contents of the file. So let's submit that for our last flag. And by this, we just completed the lab. So thanks for watching.